today we're going to write linear equations in point-slope form. So one of the things that we need to understand is we're going to find a new form of the equation. Our essential question is, how do you write linear equations in point-slope form? I want to remind you, our slope-intercept format is y equals mx plus b. It's called slope-intercept because we have our slope specified in the equation and the y-intercept specified in the equation. And with function notation, remember we could have either y or f of x equals. We've also done direct variation of y equals ax, and we've discussed that the a is actually the same thing as the slope. Point slope is what we're learning today. You've actually already seen standard form, and we'll do more with standard form in the next, but I wanted to put it in here. Point slope, it's exactly what it says. It's going to specify a point for us. Here's your x coordinate, here's your y coordinate, and it's going to specify the slope. So let's do some examples. Like I said, we'll explain this more as it comes. So here's example 1. You're given the point 4, -3, and you're told that we have a slope of 2, and you are to write the equation in point-slope form, which means we need this form of the equation. And all you have to do is substitute in. We have to be careful. This says minus y1. So we're going to get y minus -3 equals, the slope of 2. I got ahead of myself there. X minus the 4. Now, reality, we don't normally see minus and negative. What this needs to be is y plus 3 equals 2 times x minus 4. And that is your equation in point-slope form. That's what you're looking for. Now, let's say we want a equation from point-slope form. So we're going to, this is example 2, we're going to graph y plus 2 equals 2/3 x minus 3. Well, what we need to understand is this is in point, which means it gives us a point and it gives us the slope. Slope is the quickest thing to pull out. And then my point, this is supposed to be x minus x sub 1, so 3. This is supposed to be y minus y sub 1, but that's a plus. So we must be subtracting a negative, so that's -2. And we want to graph it. Let's graph it. Let's see. 3, -2. 1, 2, 3, 1, 2. And then my slope means I go up 2 and to the right 3. So 1, 2, 1, 2, 3. And then I'm going to take my straight edge and I'm going to line those points up, and then I will draw my line. Now, one thing I need to remind you is that when you are graphing and you've got 2 points that you're drawing the line through, that line needs to extend from one edge of the graph to the other edge of the graph. It's not just between the 2 points. It's the line going through the 2 points. So it needs to continue on. It needs to go from one edge to the other edge of your graph. A lot of papers that I'm seeing, that's not what's happening, and this needs to happen. Okay, so let's do example 3. Now example 3 is also coming from a graph. Okay, let me get this drawn. Okay, so there's our graph that we're starting with. And one of the things that I would do is I would identify this point. -1, 3. And this looks like it's 1, 1. And those are the 2 points that I'm working with. In order to write my equation in point-slope form, which is what I need to do, I need a slope. I have 2 points. I could do the slope formula, or I've got a graph. Can I do my slope triangle? Which comes, I'm going to come down 2, and then I'm going to the right a +2. So that tells me I've got -2 over 2, or -1. So there's my slope. And I just need to choose one of my points. I've got 2 points to choose from. I'm going to say we read from left to right, so I'm going to choose the left-hand point, which is going to be -1, 3. And my slope is -1. So I have y minus y1 equals m times x minus x sub 1. So this is y minus 3 equals a -1 times x plus 1, because I'm going to subtract the -1. So that's really adding. So there's that equation. And it would probably help if you could see it all. I apologize. Again, I used the left-hand point and the slope, substituted in. And this is subtracting a -1, so